Hello everyone. So in my previous video, I talked about conducting one sample t-test. To give a brief recap, so one sample t-test is conducted to check if a process is on target, and basically you are trying to find statistical evidence for that. So to give an example, let's say you are running a process and you find that the process is not on target. You figured out what the problem was and you have implemented a change, and then you ran the process with the change, and then you collected some data. However, if you want to know if the change that you made is actually working, you need to find statistical proof so that it can be implemented on a large scale to fix the problem everywhere. So the way you find statistical proof is by doing one sample t-test or the equivalence test, and in both these cases you are basically trying to find evidence that proves that the null hypothesis is correct. Um, in today's video, we'll be doing an extension of this. Let's say you're trying to compare two processes which are producing more or less the same product. However, you want to know if the two machines, for example, are creating parts with the same dimensions or not. So in this video, the data set that I have is film thickness of a polymer. However, the polymer was spin coated using two different spinners. So I'm interested in knowing if the film thickness that is generated by these two spin coaters at the same speed is same or not. So there are two things that you might want to know. One is the spread of the variation that is generated by these two spinners, and also you might want to know the centering. This is something I'll talk about at a later stage. Now let's look at the spread. So the way we use hypothesis testing to see if the spread is equal or not is by doing this unequal variance test. So basically here you use the variance for the sample data that you have collected. So basically in this case the null hypothesis will be that the difference between the variance is 0, and the alternate hypothesis will be that the difference between the variance is not 0. And similar to the previous discussions, if your p-value is greater than 0.05, then you fail to reject the null hypothesis because the evidence that you have against the null hypothesis is weak. On the other hand, if your p-value is less than 0.05, then you reject. This is an error. Let me correct this. Uh, so you In this case, you reject the null hypothesis and you accept the alternate hypothesis because you have strong evidence that against your null hypothesis. So now let me switch back to JMP um and show you how to do the unequal variance test. For this, we use the analyze menu, go to fit y by x, and then you choose the variable of interest, in this case film thickness, as your y response, and your categorical variable, the spin coater, as your x factor. So here at the left bottom you can see that the kind of plot the fit y by x is going to plot, it's called as a one-way plot, and then you say okay. So here you can see the film thickness values from the two spin coaters. However, you can see that it's not showing all the points, so in order to view them correctly, you can choose the rectangle option. You can go to display options and then say points to it. So now you can kind of see the spread along the horizontal axis. And another thing is, so now you want to know if these two set of spin coders create more or less the same spread. So you can do the unequal variance test for this by choosing the rectangle option and then saying unequal variances. So jump plots, quite a lot of plots, but here in this video I'll be explaining only uh, this particular test section, which is the most important for us. So here you can see that for the unequal variance test, jump does 5 different models. So I'm not going to go into the details of these models, but I'm here only talking about the how to interpret these results. So the one thing that you should see is the p-value. And as I mentioned earlier during my PowerPoint, if the p-value is greater than 0.05, then you fail to reject the null hypothesis, because the evidence that you have against the null hypothesis is weak. So now if you go back to the jump window, you can see that the p-value for all the unequal variance tests conducted with these different models, they are higher than the cutoff value of 0.05, which tells that uh, the uh, the evidence against H naught, or the null hypothesis, is weak. So you can kind of see that, so you can kind of conclude that the spread or the distribution of the data points that are created by these two spin coaters is more or less similar. Now let's move on to understand what we can do further. The other thing that you may want to do from such data for comparing is to see if the mean of the this is to mainly check if the process is on target or not. The way you do this is by checking if your mean value for these two processes is similar or not. This is very similar to the one sample t-test that we did before, but the only difference is the way you describe your null and the alternate hypothesis. Here, uh, ideally you would want the difference between the means by these two spin coaters to be same. So here you assume your null hypothesis to be that the mean difference is 0, and the alternate hypothesis that you you say that the mean difference is not 0. And when you're doing this two sample t-test, you actually have two options. When you have equal variance, then you do something called as the pooled two sample t-test. If your variance is not equal, then you do the unpooled two sample t-test. So as I discussed before, first thing you have to always check is to do the unequal variance test and see if the spread of the data is similar or not. In this case, we do know that the spread of the data is similar. So here we do pooled two sample t-test. And additionally, we have another assumption. Here we assume that uh, whatever uh, whatever changes are between the two spin coaters, by design or whatever color maybe, you're saying that whatever difference that physically exhibits between these two tools does not affect each other. So now let me go back to jump, and let's see how to do the pooled and unpooled two sample t-test. So these options are available under the rectangle option here. For the pooled two sample t-test, you choose means, ANOVA, or pooled t. So here jump plots the pooled t-test along with other summary statistics that I'll be talking about in another section of the video. But here let's focus on the pooled t-test. So here you can see that the pooled t-test kind of gives uh, data that are very similar to what we saw in the one sample t-test. So here you can see that the mean difference is about minus 0.0074. In other words, you can say that the film thickness that is generated by spin coater B is 0.0074 nanometers lower than the spin coater A, and this is the standard error difference. And you also have the t ratio, and if you remember in the previous video I mentioned that larger the t value, either in the positive or the negative direction, that means uh, the variation is too large between the hypothesized value and the mean value. Ideally you would want the mean value, in this case the mean value of the difference, to be equal to the hypothesized value. But here again from this plot you can see that the mean difference is quite far away from the hypothesized difference. And also you can see that the tails, the shaded regions below the tails, are very small. And additionally you can also see that the p-value here is 0.005 0.0045, which is less than the cutoff value of 0.05, which kind of tells that the null hypothesis, in this case, the mean difference of 0 is must be rejected because the value is less than 0.05. Additionally, you can also see from the uh, confidence intervals that 0 is not included. So the t ratio, the p-value, and the confidence interval all let us conclude that the null hypothesis, in this case, the evidence against the null hypothesis is quite strong, and that it must be rejected, or you accept the alternate hypothesis, which says that the mean values are uh, not equal to 0. Now, let me also show you a demonstration of how to do the unpooled t-test. Uh, this again can be found from the rectangle option, and you can just click on t-test, which gives the unpooled t-test. And in this particular example, you can see that the unpooled and the pooled t-test kind of generate more or less the same values.